All right, welcome back. Today we're going to be doing section 9.3, Hononegah Honors Algebra 2. Um, this is where things are going to start getting more complicated. And I did not say this on the first day, but I probably should have. This was actually a section, if you were in class, we would do without a calculator. Like everything that we are going to be doing today, I will not touch a calculator. And so I realized that you guys are going to be at home and you can have a calculator, but it's not really going to be that beneficial to you. As we do some of these things, we're going to want the answers to be exact, and your calculator is going to do as a decimal. And so again, it's not going to be beneficial to you. You can generalize a right triangle definition in trig functions. So now, what would be if I drew an angle measure and then I made it into a right triangle? So I drew this angle measure. Whoops. Hold on a second. There we go. I drew this angle measure and then I made it into a right triangle. Now we are always going to make our right triangles with the x-axis. I can't stress that enough. If I'm going to draw any angle measure, and I don't know what that angle measure would be, I'm going to draw it to the x-axis and make a right triangle. So now this is merely talking about sine is opposite over hypotenuse and cosine is adjacent over hypotenuse. So when I'm looking at a picture, this would be the opposite, this would be the hypotenuse, this would be the adjacent, because the angle measure that we're talking about is the angle measure that's made in the right triangle. So up here in this other picture, this would be the angle we're talking about. So this would be opposite, this would be adjacent, this would be the hypotenuse. So all this sine, cosine, tangent, cosecant, secant, and cotangent is what we talked about in section 9.1. Okay, SOHCAHTOA, and then cosine would be hypotenuse over opposite, and cosecant would be hypotenuse over adjacent, and cotangent would be adjacent over opposite. So this is the SOHCAHTOA that we've talked about previously. This is only going to be used when we do quadrantal angles, and we'll get into that in just a little bit. So here we go. I want to draw a triangle. 8, -6 would be the point on the terminal side. So +8, -6. So here is the spot for +8, -6. So this is the point, 8, -6. I can find the hypotenuse by doing Pythagorean theorem. A squared plus b squared equals c squared. Now, some of you are going to say, well, you can't have a side of -6. I agree with you. Okay, and when you square it, it doesn't make any difference anyway, but the hypotenuse is always a positive. You can have your other sides be negative, but again, your hypotenuse is always positive. And so there are 6 trig functions that I want to find here. Sine, cosine, tangent of this angle measure right here. So I drew a triangle using the point 8, -6 with the x-axis. And so sine of that angle would be opposite over hypotenuse, and I can reduce. Cosine would be adjacent over hypotenuse, and I can reduce. Tangent would be opposite over adjacent, and I can reduce. So now the next ones are cosecant, secant, and cotangent. Now, from what you learned previously, a sine is opposite over hypotenuse, so secant would be hypotenuse over opposite. And I didn't draw that very well, so we're going to go back here. So notice it's the reciprocal of sine. Secant is the reciprocal of cosine. Cotangent is the reciprocal of tangent. So when I start talking about cosecant, secant, and cotangent, it's just merely looking at sine, cosine, and tangent and doing the reciprocal of those. All right, now for one of the more confusing slides of the day. We talked about this previously, that sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. And so when I am looking at a picture, the sine is always the y value if the radius is 1. Notice in this little explanation over here, they put a 1 down there. So if I'm talking about the unit circle, we're talking about a circle with a radius of 1. So every single time, if I'm talking about a point on the unit circle, Sine of any angle is always the y value. Cosine of any angle is always the x value. You need to know that. Sine is y, cosine's x in a unit circle. So I want to specify that. In a unit circle. Sine is y, cosine's x. Now, tangent's a little bit different, and we're going to get to that when I get down to here at the bottom. It is convenient to use the unit circle when doing trig functions that are quadrantal. Quadrantal angles are angles in a position when the terminal side is on an axis. So here's what we're talking about. If I have an angle that ends up on one of these axes, that is called a quadrantal angle. Every multiple of 90 degrees or every pi over 2 is a quadrantal angle. So if I'm talking about a quadrantal angle, I'm talking about an angle that is on the x-axis or on the y-axis. So it's on an axis. Now, it's important to understand that we're talking about, and I'm going to change colors here, we're talking about a unit circle in which the radius is 1. So when you're talking about a radius of 1, this would be the point 1, 0. This would be the point 0, 1. This would be the point -1, 0. And this would be the point 0, -1. Why is that important? Okay, because what it will allow me to do, because anything on the unit circle, the sine of any angle on the unit circle is the y value, and every cosine of any angle on the unit circle is the x value. And then tangent is a little bit different. Tangent is sine over cosine, which means tangent is every y divided by every x. So again, if I want tangent, okay, you're talking about y over x. So again, this is only on the unit circle. So here's what I do when I'm asked this question. Again, you are not allowed to use a calculator. Even though I'm going to have you test this on a calculator, you're not supposed to be using a calculator. So here we go. Draw 90 degrees. 90 degrees ends up on the y-axis. If it ends up on an axis, write the point as the unit circle. Now, look at your trig function. It's asking for cosine. Cosine of any angle on the unit circle is the x value. So guess what the cosine of 90 is? Because the x value of that point, the cosine of 90 is 0. Test me. Go to your calculator right now. Let's take a second. Type in. Now, please make sure your calculator is a degrees mode. And type in cosine 90. I bet you got 0. So again, this is why it's 0, because the x value on the unit circle at 90 is 0. So now let's do the next one. I'm going to do the sine of 0. 0, you don't have to go anywhere. Ultimately, the terminal side and the actual initial side is the same spot. So again, this ends up on an axis. Write it as a point of the unit circle. Sine of any angle on the unit circle is equivalent to the y value. So the sine of 0 on the unit circle is 1. And I just messed that up. Sorry, confused everybody. Sine of 0 is 0. So I feel like I'm going to do another example here. So again, kind of give yourself a spot over here. Let's do another example. I feel like we need another example. What if I asked you for the cosine of 180 degrees? Draw 180 degrees. It ends up on an axis. Anytime something ends up on an axis, write the point from the unit circle. Now, cosine is x, sine is y. The answer to this question is -1. If you went to your graphing calculator or went to a calculator right now and typed in cosine of 180, you would get -1 because 180 degrees on the unit circle has an x value of -1. More angles. Now we're doing things in radians. Again, we got to get better at radians. 3/2 pi. I need to draw 3/2 pi. So here's half a pi, 1 pi, 1.5 pi. Since it ends up on an axis, write the point from the unit circle. Now it's just a matter of what trig function are they actually asking me. They're asking me for sine. Sine of any angle on the unit circle is y. So the answer to this question is -1. Now, you're not going to be able to really check this on a graphing calculator unless you put it into radians mode or you converted it into degrees. So this would be the sine of 270. And so the sine of 270 on a graphing calculator is -1. Tangent. Tangent gets a little messy. First, let's draw -5 pi. So we're talking about negative, so we're going this direction. We're going clockwise. There's -1 pi, -2 pi, -3 pi, -4 pi, -5 pi is on the axis. Always write, anytime you get a number on the axis, always write it as a point on the unit circle. Tangent of any angle on the unit circle is y over x. So now, in this case, we got y over x. And so the tangent of -5 pi is 0. Because 0 divided by -1. Now, tangent can sometimes be undefined. Think about that. Okay? If I had an angle measure in which the 0 was on the bottom, now you're talking about undefined. So tangent can have some undefineds. Sine and cosine cannot. Sine of any angle measure, okay, the maximum for sine is 1, and the minimum for sine is -1, and there is no undefineds. But tangent can have some undefineds. Big topic of the day. Reference angle. An angle measure that is formed by the terminal side and the x-axis. Now, look at each one of these pictures carefully. If I drew an angle measure in the first quadrant, the angle that is made with the x-axis is the answer. Now, the second quadrant, if I do something in the second quadrant, it's the angle measure between the terminal side and the x-axis. So here again, here's your reference angle and your reference angle. The reference angle is always the angle measure that is made with the x-axis. So I'm going to draw another picture here just to show you. I'm going to draw something in the third quadrant. This one right here, that is your reference angle. So it's the angle measure that is made between the terminal side and the x-axis. So when I draw a picture, if I draw -120 degrees, so over here, I'm going to draw -120 degrees. What angle measure is made between the terminal side and the x-axis? So again, if you went 120 degrees, then there's 60 degrees left over between the terminal side and the x-axis. So this angle measure is 60. Next one, and again, you can do all reference angles in degrees, and I know that's going to be a little bit confusing. Next one, 5 pi over 3. So I'm going to draw 1 2/3 pi. What angle measure is made between the terminal side and the x-axis? Here's what I will tell you, and you need to memorize this. This needs to be ingrained in your head. Every time you have a third, the reference angle will always be 60 degrees. Every time you have a sixth, the reference angle will be a 30-degree reference angle. Every time you have a fourth, the reference angle will be 45. Every time you have, and everything else will be quadrantal. So we only have a third, a fourth, and a sixth. Okay, if you have a half, that's a quadrantal angle. So again, this is the only ones you have to deal with. So this one has a 60-degree reference angle. What this will allow us to do is, without using a calculator, we now can come up with trig functions. Okay, so again, this is what we just talked about, but I'll do it again. Every time you have a pi over 3, that is a 60-degree reference angle, a 45-degree reference angle, a 30-degree reference angle, and this one is a 90 degrees, but again, you don't have to worry about that one because that one is a quadrantal angle. The reference angles to evaluate trigonometric functions. So this is where the I don't need a calculator anymore comes into play. Here's the order of which you should do this. 1, draw a 150-degree angle, and then make a triangle with the x-axis. 2, figure out the reference angle. The angle, the degree that's between the terminal side and the x-axis. Next, all right, now this goes back to our 30, 60, 90, 45, 45, 90 ratio. So down here, when we did this last section, every single 30, 60, 90 triangle has a 1 square root of 3, 2 ratio. Every 45, 45, 90 triangle has a 1, 1 square root of 2 ratio. Why is that important? I know that this is a 30-degree reference angle. So opposite of 30 is 1. Opposite of 60 is the square root of 3. And the hypotenuse is 2. Now, adding another degree of difficulty here. Because this goes to the left on the x-axis, this is actually a negative value. Cosine of 150. Cosine is adjacent over hypotenuse. The answer to this question is negative square root of 3 over 2. Now, if you, again, we were supposed to do this without a calculator, and I did this without a calculator, but I now want you to just check the fact that I know what I'm talking about. On your calculator right now, type in cosine of 150. If it is in degrees mode, you're going to get 0.86602. Now type in negative square root of 3 over 2. Again, you will get negative 8.866025. So we figured out what the cosine of 150 is as an exact value, not as a rounded decimal like your calculator would give you. There's a lot to take in there. So I'm going to slowly go through the next one. Draw 225. 225 is in the third quadrant with a 45-degree reference angle. The ratios of a 45, 45, 90 is 1, 1, square root of 2. Since this one is to the left, it's negative. Since this one is down, it's negative. The hypotenuse is always positive. So regardless of the trig function, I'm going to cross this out. Regardless of the trig function, I would have drawn the exact same picture. Now, tangent. Tangent is opposite over adjacent. Well, if I did opposite divided by adjacent, negative 1 divided by negative 1 equals 1. I bet you if you typed tangent of 225 into your calculator right now, you would get 1. Now we're going to do the exact same thing in radians. Sine of 2 pi over 3. Draw 2 pi over 3. 2 pi over 3 is located in the second quadrant with a 60-degree reference angle. Ratios. 1 square root of 3, 2. Notice the opposite of 60 is the square root of 3. Opposite of 30 is 1. This one goes to the left, so it's negative. Sine. Sine is opposite divided by hypotenuse. The answer to this question is the square root of 3 over 2. So again, draw the angle, find the reference angle, put the correct ratios on the correct sides, and then use the sides to figure out the trig function. So negative 7 pi over 4. So here's negative 1 and 3/4 pi, which has a 45-degree reference angle. 1, 1, square root of 2. Cosine. Cosine is adjacent over hypotenuse. Adjacent divided by hypotenuse. Now, we are not going to let you leave your answer with a radical on the bottom. So I'm going to multiply both top and bottom by the square root of 2. So again, the cosine of negative 7 pi over 4 is equivalent to the square root of 2 over 2. You are not allowed a calculator on this. When you get into trig and when you get into calculus, they're going to expect you to be able to understand radians and be able to understand how to do radians without using a calculator. Find the exact value. Again, we're just drawing negative pi over 6. So here's negative pi over 6 in the fourth quadrant. Every sixth has a 30-degree reference angle. So it's important to understand every third is a 60-degree reference angle, every fourth is a 45, and every sixth is a 30. So this is a 1 square root of 3, 2 ratio. Because this is down, it's negative. So now, sine. Sine is opposite over hypotenuse. The answer to this question is negative a half. I bet you typed in your calculator right now, sine of negative 30, you would get negative a half. Draw the angle measure. So again, this goes back to earlier when we talked about drawing angle measures. Okay, we're drawing 4 pi over 3. That is 1 1/3. Every third is a 60-degree reference angle. So now, putting the correct ratios opposite the correct sides. Opposite of 60 is always the square root of 3, which means opposite of 30 is 1. This goes to the left. This goes down. Cosine. Cosine is adjacent and hypotenuse. The answer to this question is negative 1 over 2. The hypotenuse is never negative. Only the side lengths going to the left and the side lengths going down are negative. Homework assignment, and this one's going to be a challenging assignment. I'm going to talk to Ms. Kensel and myself, and we're going to talk about how many days you might need for this particular assignment, because I think there's going to need to be a day of working on it and then a day of maybe asking some questions. So again, please show up to a Zoom meeting. Please show up to any type of discussions about understanding the material, because this can be challenging. Good luck. Hopefully be safe, and we'll see you soon, I hope.